You already know about solve by graphing, but a quick review. This equation is not in standard form, but because you have algebra skills, you can set the equation equal to 0 by moving the 4 and the minus 5x over to the other side. Once you have it in standard form, you graph it, and you look for your x-intercepts, otherwise called your roots or your zeros, and x is -1 and x is 4. That means these are the solutions to that equation. These are the x values that if you plugged it into the equation, it would make it true. But I have some news for you. We have some new information coming your way on a twist on the graphing method. So with this new method, it's still going to be by graphing. We're going to be able to solve this equation without rearranging it and setting it equal to 0. We're going to get the exact same answer as the previous method, but we don't have to turn it into standard form set equal to 0. And here's the procedure. I see I have a left side, x squared minus 8x. I make that its own equation and I graph it. But on the same graph, I take the right-hand side, I just turn that into y equals 4 minus 5x, and I graph it. So these are those two equations, and if you take the time to do this on Desmos, you'll see this. And those two equations intersect in two different spots. They intersect at -1 comma 9, those are the coordinates, and 4 comma -16. But those intersection points, what I really care about is only the x value of the intersection points. X value of -1, an x value of 4, and those are my solutions. X equals -1 and x equals 4 by just looking at the x coordinates of the spots where they intersected. That's the exact same answer I would have gotten when I set it equal to 0 and looked for the x values of the intercepts. So this new method just offers you possibly a quicker way to get to a solution by not having to rearrange and set equal to 0.